PSP, the problem-solving process, which I talked about briefly that one day. Draw a picture, read the problem, label your frame of reference, and move on, right? This is something that I want you to practice when you're doing problems, and so I want to show you how I would read a problem and how I would work that out, and then I want you to try and practice this as we go forward doing your problems in your homework, okay? So this is problem number 11 on homework Simple Motion 1, right, which is actually problem number 19 out of chapter 2. It says a sports car moving at a constant speed travels 110 meters in 5.1 seconds. If it then brakes and comes to a stop in 4 seconds, what is its acceleration? Express the answer in terms of g's, where g equals 9.8 meters per second squared. Take the positive direction to be the direction of travel, right? So I just read it to you, so we'll read it again, and I'll draw a picture, right? It says a sports car is moving at a constant speed. It travels at v, covers a distance of 110 meters in a time frame of 5.1 seconds. Right? All I've done is read the problem and draw it accordingly. Right? At this point, it then stops. Right? And so it goes from V naught across some distance that I don't know to here to V equals 0. Comes to a stop. Does that make sense? And so I've got two different scenarios. One where from here to there, A equals what? From here to there, A equals 0. Perfect, good. Because if V is constant, A is 0. Here, A is the question. Right? That makes sense? So I also know that here the time is 4 seconds, 4.0, to keep significance the same. So part of the issue is that when I start looking at these, I've already got too many A's and V's and things going around the page, right? And so what I like to do is organize them. So I would say that this is picture 1, right? This is scenario 1, and this is scenario 2, which means that this is now A1, V1, V2 naught, V2 final, A2, time 2, T1, and D1, right? The questions are going to get more complicated, not with just beginning and end, but also dimensions, horizontal and vertical. And so you need to make sure that you keep those things organized so that you know which ones you're looking for as you go through the work, right? All the time, you are going to have V, V naught, D, A, and T, right? And so I make a list. In this case, I'm going to say these are all 1s first, and then I can go through and do it again, V2, V2 naught, D2, A2, T2, right? Just keeping organized with everything I have going on. Before I go any further, I want to stick the frame of reference in there. This is a one-dimensional problem where they asked me to make going in the direction of motion positive. So I'm being consistent with the given problem. That make sense? That is drawing the picture in my book. That make sense? It is not about what the car looks like. It is not about the brake smoke. It is about the arrows that represent the various vectors. Vectors are magnitude and direction. Things that I did not do is put double-headed arrows because the car doesn't go back and forth between these things. It goes from here to there only. Right? The speed is only forward and so on. What I didn't draw is any curved lines or anything that doesn't match up to the frame of reference. All right, so then going down through this list, V is constant, D is 110, A is 0, T is 5.1. If for some reason any of these were not in SI units, my first step would be to convert these and write them in SI. Here I know that this is constant, but I don't know what it is. But I know that this will then be V naught in the second picture. Why?
It's the starting velocity.
Exactly. Because if the car moves over this space and is moving at a constant speed, when they hit the brakes, V2 naught is the same as V1 in the first picture. Right? That's the way I'm able to transition across from picture 1 to picture 2. There will be lots of problems like that where you have to figure out something in a different dimension or a different situation in order to translate it over across. Best example is jumping on a trampoline, right? Jump off a building, you want to know how fast you're hitting the trampoline before you can understand what's going to happen on the trampoline, right? So you're going to use each position for information. I know that if V is constant, then this obeys V equals D over T, right? And so I should be able to just put V equals 110 divided by 5.1 and figure out what V is, right? This is V1 or V1 naught because they're the same. I'm going to utilize that answer over here, and then I'm going to repeat the process, right? When I finish, I should get A as a number, right? That's the goal. It says, what is the acceleration? But then it says to express it in terms of G's, right? And something that this is very common on the AP test. AG is the acceleration of gravity, plus or minus 9.8 meters per second squared, right? The reason why you are asked to present it as G's is simply as a reference, because right now you are under 1G, right? Because you are on the Earth and you are sitting, and the reason why you are sitting is the attraction to Earth is holding you in your chair, right? Which means that if you were to experience 2Gs, it would feel like you are sitting on your lap, right? You would be twice as heavy because the acceleration would be twice as much. Does that make sense? That's the only reason for the reference, because if your acceleration is less than a G, then you would feel lighter, right? And this is the experience that the astronauts get on the moon, right? So the reality is that the number of G's, right, is simply A divided by 9.8. So don't get thrown by that. This will just give you a number. Oops. Sorry. It's just an integer number or a decimal number of whatever it is. Now, I didn't go through all the math here, but you get a sense of this is a relatively simple problem, right? And I took up almost an entire page to solve it. Because the better off my workspace is, the more sense the picture makes, the better off you will be, the harder the situations get as we move forward, right? So as you're doing problems, try and build out a system that you can look at that later you wouldn't need this book in order to know what the scenario is, right? In order to study for physics, you have got to be able to look at your work and know what the question was, right? And so I didn't write the question down, but I can tell based on writing question marks and keeping track of things on the page what the point of that question was moving forward, right? And keeping your list straight and organization is a big key for success.